Welcome, simple harmonic motion spring system. Now problem number 3. Let's solve problem number 3. The springs of a 1,700 kilogram car compresses 5 millimeter when its 66 kilogram driver gets into the driver's seat. If the car goes overbound, what will be the frequency of oscillations? Ignore damping. Here we are given the mass of the car, mass of the driver, and the displacement. Now we have to find the frequency of oscillations. Given data, these are data. We have mass of driver. We have big mass of car. Kilogram. We have displacement 5 millimeter. We convert it into meter. Let's convert it into meter like this. Now we have to find the frequency. The weight of the man equal mass times gravity. The spring force equal like this. Let's apply the Newton law for the vertical springs, or the second law of Newton, which says that the spring will be in equilibrium when? For our spring to be in equilibrium, we will have the total force, the sum of force must be equal 0. Forces I have here, it's the weight of the driver and our spring. Now you see I have weight and spring system like this. I'm going to solve for car because I don't have it. Solving for car, you have m times gravity over x get. Let's trace the value, the given value. We have mass here, and displacement. Now replacing 6 kilogram times 9.8 over 5 times 10 over. Now we get 1, 2, 9, 4 times 10 to the power 5 Newton per meter. This is a spring constant. Now the frequency of oscillation, let's find the frequency of oscillation. Frequency of oscillation equal we use this relation, the frequency of oscillation here. In finding the frequency of oscillation, we use mass of car plus mass of driver. Now you get car we have already find the value of K, which is equal to over now we get 1.362 Hertz. Rounding off, I find 1.4 Hertz. This is a required frequency of oscillation in our problem. We had to find the frequency of oscillation. Thank you for watching, dear friends. Let's meet in the next video where we will solve the problem number 4.